Chapter 7, Section 2 is on the power properties. So the first thing I have here for you is the different properties and all the different rules. So you might want to pause this and write those down, and then unpause when you're ready to see the example. So if we look at product of powers, if I have two different bases here with two different exponents with the same base, then I can just add them. So I should get c to the 13th. If I just have one base, then I'm going to multiply my exponents to get x to the 12th. These are the first two that most people get confused. So the same base, if I see it twice, and here's kind of my trick. If I see this twice, 2 underlines is a plus sign. In the second example, I only underline one base, so one base is a multiply. So that's the most commonly confused one. So 2 bases is add, 1 base is multiply. Power of a product just means I need to distribute. So I need 2 to the 4th, s to the 4th. So my final answer would be 16 s to the 4th. Quotient, okay, how do I remember this one? If I'm dividing with the same base, dividing looks like a subtraction sign to me. So 11 minus 7 is 4, so 2 to the 4th is 16. When I have a number as a base, like that example, you can kind of just treat it as like x to the 11th over x to the 7th, and then that would give me x to the 4th. It just so happens that at that point, 2 to the 4th gives you a simplified number. So if you've got a number that is your base, just treat it like a variable. Okay, power of a quotient means, again, I distribute. So I have to distribute my square to the top, so x squared, and 3 squared is 9. Okay, common mistake there is x squared over 6. It is not 3 times 2. These are powers, so 3 squared. And the zero exponent, anything to the 0 power is 1. So there's kind of your basic examples. Now we'll try some trickier ones. So we've got 3a squared b times 5a to the 3rd b. Okay, so numbers are just numbers. So 3 times 5 is 15. And now I look at my a's because the bases are the same. So I have a squared and a to the 3rd. So if I can underline 2 of those, that's going to give me a to the 5th. Okay, then I look at the b's because those are the same base. I have b times b. Well, that's really b to the 1st times b to the 1st. So that gives me b squared. Okay, so you look at the numbers that you can put together. 3 times 5 is 15. A to the 2nd, a to the 3rd is a to the 5th, and b is b squared. Okay, in example B, I have to do a couple things first. First thing, I need to leave the top as z to the 18th. On the bottom, I have z to the 5th squared. Realizing that I have one base means I need to multiply. That gives me z to the 10th. When I am dividing with the same base, I really subtract. So that gives me z to the 8th as my final answer because 18 minus 10 is 8. Okay. Example C looks a lot like example A, just without the parentheses. So you take a look at numbers. So I've got 4 times 5. There's really a 1 out here, times 1. So my numbers give me 20. Now I'm going to see what has the same base. I have an n squared and an n. So 2 bases that I can underline is an add. So I have 2 plus 1, so that gives me n to the 3rd. If I go ahead and look at my next variable, I've got a z there. I've got a z over here. Again, if there's no number written there, it's a 1. So that gives me a z to the 4th. And again, I try to write these in alphabetical order. Now I find my m's. So I've got 1 m here, 2 m's there. So that gives me m to the 3rd. So my final answer is 20 m to the 3rd, n to the 3rd, z to the 4th. Okay, so just look at what has the same base and put those together. Example D, okay, I've got some quotients. Just like any set of parentheses, I need to distribute my 4 to both of those. So I get x to the 4 over 16, which is 2 to the 4th power. Okay, that is not an 8. Okay, these are exponents. Times, and then if I take my second parentheses and I distribute again, 10 to the 3rd is 1,000 over x to the 3rd. Now I have 2 fractions being multiplied, okay, and numbers are just numbers. So remember, you multiply fractions straight across. So that gives me 1,000 x to the 4th over 16 x to the 3rd. And now numbers are just numbers, so I'm going to do 1,000 over 16. Okay, so 1,000 over 16 is 62.5. That's just dividing, okay, because numbers are numbers. And now because I have a variable with a base up here and a base down here, I'm going to subtract, and 4 minus 3 is 1. So my final answer will be 62.5x. Okay, example E, again, more parentheses, always distributing. Okay, if you don't want to remember all the rules, just remember I have to distribute. This is going to be 12 to the third, which I'm not sure, so I'll just write 12 to the third. R to the third, because that's really an exponent of 1, and 1 times 3 is 3. Then times 12 squared r to the fourth. Okay, so this is kind of an interesting situation where I have a 12 and a 12, a number, acting like a base. So what I'm going to pretend is I'm going to pretend those 12s are x's and say, okay, that's x to the third, r to the third, times x squared, r to the fourth. So I'll take a look at my x's. I have two different bases, which means I'm going to add them. So that's going to give me x to the fifth. Same thing with the r's, r to the seventh. Now, I didn't really have x's in my problem. I had 12s. So I'm going to leave my answers 12 to the fifth, r to the seventh, by kind of simplifying that back out. Okay, so over here, if you want to write a little note, you let x equal 12 so that you didn't get so confused with the numbers. Now, do I actually want you to find 12 to the fifth? Absolutely not. Okay, so if they give it to you in terms of 12, treat it like a variable and then leave it like a variable, so that final answer will be 12 to the fifth. Okay, let's try a few more. Let's take a look at f. Okay, again, an exponent on the outside means I need to distribute that. So here I have a negative 9 to the third power. So I'll just write that out, negative 9 to the third. And then I have z to the fifth to the third. That's one base, which means I multiply, so z to the 15th over 9 squared z to the 11th. Okay, so make sure you're separating different things. So here, the first thing I see is I have a 9 on the top and a 9 on the bottom. Okay, and those are my bases. So I have 9 to the third over 9 squared, which means I would subtract to get 9 to the first. Now I have this negative. A negative times a negative times a negative is negative. So my final answer is going to be negative, because then I was dividing by a positive 9 on the bottom. Okay, and then z to the 15th over z to the 11th is z to the fourth, because again, when you are dividing with like bases, you are going to subtract the exponents. Okay, example G, again, we are distributing here, and you have to distribute to every single thing. So I hope when you look at this fraction, example G, you see 4 different things. You see a 2, you see an x to the third, you see a 3, and you see a y to the fourth. Okay, so your most important thing, and maybe you want to star this, is numbers are separate from variables. Okay, so you have to treat them separately. So I needed to get 2 squared, which is 4, and then x to the third to the squared is going to be a multiply, so x to the sixth. Then I need to do 3 squared, which is 9, and then y to the fourth squared is y to the eighth, because I just have one base, so then I'm multiplying. Okay, so every single thing in there has to be raised to the second power, distributing it to all, okay, numbers and variables. I can't simplify because 4 over 9 is reduced, and x and y are just different bases, so that's going to be my final answer for example G. If I look at example H, I've got a lot going on. Okay, so what I would do is kind of treat the top as one part and the bottom as a number before I start to simplify. So on the top, I have y to the third times 8y to the fifth. So that's going to give me 8, because numbers are just numbers, and 1 times 8 is 8. Now I have two different bases, y to the third and y to the fifth, which means I'm going to add them because there's two bases. So 3 plus 5 is 8. On the bottom, numbers are numbers. So I'm going to get 6 times 2, which is 12. I have y squared and y to the fourth. Two bases means I add them. So y to the sixth. Now I can go ahead and reduce. Okay, 8 and 12, numbers are just numbers. Again, keep them separate from their variables. 8 and 12 will reduce down to 2 over 3. So I'll keep my fraction 2/3. And then my y's are separate, and I have a y to the eighth over y to the sixth. Subtraction is what we do when we have a division sign. So I've got y squared. Okay, and that's going to go on top. So I'm going to have 2y squared over 3 for my final answer. Okay, then we'll try a one-story problem. Part A of a multiple choice exam contains 25 questions, and Part B contains 36 questions. There's three possible answers. How many ways can a student answer all of the questions on the test? Okay, so if there's 3 possible answers, there's 3 ways I can answer the first question, and the second and the third. Okay, so 3 times 25, or 3 to the 25th for Part A, and 3 to the 36th for Part B. So altogether, that'd be 3 to the 61st ways, because there's 61 questions on the test. Now, Part B says if the student guesses what is the probability, well, the probability of getting one of them right would be 1 out of 3. For each question would be 2 to the 61st. Again, you can leave these Okay, expressions, just like they are, because I don't need to know what 3 to the 61st is. And it's a huge number, which is going to confuse you in your calculator. So you can just leave that. Okay, so that is the power properties. So go ahead, stop here, think, what do you still have questions about? Bring those to class tomorrow.